Hey guys, today in YouthSTEM we're going to be exploring the concept of torque. Now, in physics, you may have heard that torque has the equation T, or torque, equals radius times force. But what exactly does this equation mean? I'm going to give an example here to illustrate the concept of torque. Let's say we had a seesaw. It has two endpoints and then a triangle in the middle, which is sort of where the balancing point is. Let's say I were to put an object on both sides. Let's say I were to put a barrel here that's filled with water. And then on this side, I were to instead put a feather, right? So it's very light. Now, which would you expect to tip the scale, or which direction would you expect the scale to tip in? Now, most likely, you would probably say that the scale would tip in the direction of the barrel. So instead of looking more like this, it would look more like this. Why is that, though? Well, it's because our barrel here is exerting a torque. So in essence, the barrel is taking our radius here and putting a torque at a distance from it, thereby pushing or exerting a force on the seesaw. Now, the feather here also exerts a torque. However, it is nowhere near in magnitude as the barrel because the barrel has more weight. In this case, our radius is the distance between the seesaw, the point of rotation here, which is represented by this triangle, and where the barrel is actually placed. And our force equals mg. With this being said, we can definitely ensure that the barrel is the one that exerts a greater torque on the seesaw because it has a higher mass. So if we were to extend this concept a bit, instead thinking of a seesaw, we were to think of the case of a wheel. If we were to exert a torque on this wheel, it's also acting at a radius from the point of rotation, which is right here in the middle. Now this torque here, which is radius, and our force is manually applied, would cause the wheel to rotate. For this reason, we say that torque can cause rotational acceleration. Now, this rotational acceleration is just like, let's say, a translational acceleration. In this case, let's say that'd be the same thing as having a force being applied to just a regular old block. However, torque is sort of the rotational equivalent. In this case, there's a radius acting upon a surface. So here's like a seesaw here that's similar to our earlier example. Now, what if we had a torque that acts on a seesaw like this? I'm just going to show the right side to simplify our example here, except for our torque doesn't actually act straight down. Instead, it acts at an angle. Let's say this were the angle. What would we do here? Well, our radius is still the same as if we're going straight down, but what's different is the force. So if you've covered vectors before, if not, we'll soon have a video about that. But in essence, only one component of this force is acting upon the seesaw, and that is the vertical component. Now, so this is what we're really trying to find, is this part here. So how would we find that? Well, according to our physics equations here, that would be found using sine. So that is, let's say this were our original force, F not, this would be RF sine theta to find torque, because this is the sine F naught sine, because it's a vertical component. So then we know what torque is exacting directly on our axis of rotation, which is this thing. I'll write it down. Axis of rotation. Anyways, that is a basic overview of torque. I hope you found it helpful. There are just a few things that I want you to take away from this video. The first is that torque is equal to radius times force. But when the force is not acting directly perpendicular to your axis of rotation, torque can also equal RF sine theta, or RF force, in this case, y, the y component of force. So this pretty much wraps it up for introducing the concept of torque. I hope you found this helpful. Thank you.